All right, algebra students. So we talked about two different kinds of things in class today, and they were both about graphing. One was just kind of a reminder about how to graph, making sure that we have the right sense for where points go on a graph when we give you a point. And we related that to input-output tables. Usually we talked about the x's being the inputs and the y's being the outputs. And the second thing we talked about is what story can a graph tell when you see something graphed. So we're going to talk about both of those things, and then we're going to rely on them pretty much for the rest of the year. So let's go ahead and jump into this. Plot each of the following points on the coordinate plane. Label each plotted point with its ordered pair. And so -2, 5 is going to be first. I'm going to color coordinate this so we can see it nicely. So this first one I'm going to plot in red, -2, 5. So -2, 5. The -2 is the x-coordinates. That means I'm going to start at the origin. So my pen is right here right now. And I'm going to go to the left, 1, 2, and then +5 is up 1, 2, 3, 4, 5. And so I should get a point right there, and I'll get rid of this other stuff. And so I have my point, and that is the point -2, 5. So this literally says left 2, up 5 from the origin. All right, so let's try the next one. In purple, 1, 3. So I'm going to go from the origin, I'm going to go over 1 and up 1, 2, 3. And so I get 1, 3. So that literally says write 1 up 3 from the origin. I'll get rid of my work here. Of course, you can do the same thing as long as you're working in pencil. Let's go with green. So 2, -3. So 2, -3 means from the origin go over 1, 2, and then down 1, 2, 3. And then I'll make my point. So that is 2, -3. That literally says right 2, down 3 from the origin. And so the last point that we have to plot here we'll do in blue, -4, -1. So from the origin, I'm going to go -4, 1, 2, 3, 4. That's left 4. And then -1 is down 1. It was -1, wasn't it? Just double check. -4, -1. And so I've got my coordinates plotted, and this is -4, -1. And I think we're in good shape. On the same coordinate grid used for question 1, add a point in quadrant 3 that has an x-coordinate larger than the y-coordinate. Label a point with its ordered pair. Okay, so quadrant 3, I'm going to do this in black. Quadrant 3 is down here. And usually we don't write a 3, we write the Roman numeral 3. That means that we're in quadrant 3. And so in quadrant 3, if you look, you'll see that both the x's and the y's are negative. And so I need to pick two negative numbers for my coordinates, and I need to make sure the x is larger than the y. And when I think about negatives, I have to remember that the number that looks larger is actually smaller. And so I'm going to choose -2 for my x, and then for my y, I need a number that's smaller or less than -2. And so I'm going to do -3. And so from the origin, I'm going to pick the point. I'll go over 1, 2, and then I'm going to go down 1, 2, 3. And that's -2, -3. All right, on the same coordinate grid used for question 1, add a point in quadrant 4 with a y-coordinate that is opposite of the x-coordinate. Label a point with its ordered pair. And so quadrant 4 is this quadrant over here. And so what you can notice in that quadrant is that the x's are positive and the y's are negative. And so since x's are positive and y's are negative, I can choose an x value. I'll choose 4. And then I have to choose its opposite for the y value. So -4 is what I'll choose, because 4 and -4 are opposites. When you add them together, they make 0. So I'm going to plot that. Start at the origin, over 1, 2, 3, 4, and then down 1, 2, 3, 4. and I'll plot my point. And there we go. Looks pretty good. I'll label it 4, -4. And we've got a nice weird looking graph there with multiple colors and a ton of points. Okay. This graph shows Tina's new cell phone plan. Use the graph to decide whether each of the following statements is true or false. Provide evidence for your answer. Okay. If Tina talks fewer than 100 minutes a month, she does not have to pay anything. Alright, so fewer than 100 minutes a month. So that would be over here in this section. And if I look at that section of the graph, let's say that she talks for like 50 minutes, which would be right here. I go up to the graph, and it looks like her cost is $20. And so I've just found a counterexample to that claim, and so it's got to be false. For 50 minutes, the graph shows that she has to pay $20. Okay, the plan has $20 minimum monthly charge. Let's look. I'm looking and I see no part of the graph anywhere less than 20. So there's no points and no lines graphed in that part that I've highlighted there. But there is charges here. And it looks like the charges never get below this $20 mark. And so I think that that is true. I'm going to write that the line never goes below $20. Okay. If Tina talks 500 minutes in 1 month, she will pay $100. So if I know she's going to pay 500 or going to talk 500 minutes, which is a heck of a lot of talking. Who talks on the phone anymore? Just text them. We go to 500. We go straight up. We hit the line, and then I look and I go over to see the charge. So I go up from 500 minutes because that's what I know. Then I go left over to find the number of dollars, and it looks like 60. And so I'm going to say that it's false. The line shows she will pay $50, $60 for 500 minutes. Okay. The plan includes up to 300 minutes at no additional charge. So we know they only charge $20 minimum. Let's go to 300. If I go to 300, I notice that something changes about the graph. Before 300, the graph was totally flat. And then after 300, it starts increasing. It goes up. And so when I think about that, it seems that it must be a true statement. The graph is flat all the way up to 300 minutes. It means anything from 0 to 300 minutes costs only $20. The plan charges the same amount for 600 minutes as 500 minutes. I think that's false. I'm going to go back up here. At 500 minutes, it charges 60, but this is in the part of the graph that's increasing. And so at 600 minutes, it's 80. And so that's false because 500 minutes is 60, and I'll put dollars, and 600 minutes is $80. The plan charges twice as much for 600 minutes as for 300 minutes. Let's look. That might be true. I can't tell just without looking. So twice as much for 600 minutes as for 300 minutes, which kind of makes sense if just intuitively it seems like you double the minutes, you should double the cost. But let's look. 300 minutes costs 20, and 600 minutes costs 80. So that means that it's false. $20 times 2 equals $40, but 600 minutes costs $80. So it's way more than double. Okay, let's look at this arm span and height set of problems here. Okay. Person's arm span is the distance measured from fingertip to fingertip when the person's arms are outstretched. Similarly, a bird's wingspan is the distance from the end of one wing to the end of the other wing when the bird's wings are outstretched. Typically, a person's arm span is very close to the person's height. For example, if a person is 68 inches tall, his or her arm span will be close to 68 inches. But because everyone is different, a person's actual arm span will often be a little bit longer, a little bit shorter than his or her height. This graph shows the relationship between the height and arm span of 3 people and 2 other kinds of animals. Using the clues provided, match each point with the correct person or animal, put your answers in the table, provide evidence for each answer. Okay, so I think what they're going to do is they're going to give us some clues, and we're going to have to try to interpret this graph based on those clues. So let's just read it a little bit. So it looks like B has the largest arm span, but it's also short, and that's because it's way out here in the arm span, but it doesn't go up very high. So I'm just going to make a note for myself. Short, big arm span. Which means that this one that is here at E is tall because it's way up high, and it is also big arm span. So tall, big arm span. C and D have the same, look at this, they're on the same height. And A looks like it is kind of tall, little arm span. Okay, so we've got some ideas there. Let's see which ones work for us. So far, all I've done is I've just read the problem really critically to make sure I understand what's going on. Yao Ming is a very tall bass player who's about 7'5". 7'5". His arm span is said to be 7'4". So he is tall with a big arm span, and so I think I'm going to use some highlighting here. Yao Ming is tall with a big arm span, so it seems like Yao Ming is probably E. And so let's look at the table we're supposed to fill out here. Yao Ming is E. He is tall with a big arm span. Cool. All right, let's try the next one. Michael Phelps and Candace Parker are both Olympic gold medal winners. I guess I don't need to. They are both 6'4" tall. Both have arm spans that are longer than their height. However, Michael Phelps has an arm span that is longer than Candace Parker's arm span. So they are the same. They are both 6'4". Okay, so that means that Michael Phelps and Candace Parker are C and D because they're the same height, because they're at the exact same level on the height axis. So if we trace this back here, they're at the same height. Okay, so since they're the same height, and I know that Michael Phelps has a wider arm span, I can tell that this is Michael Phelps and this is Candace Parker. Because the closer you are to this side of the arm span, the smaller arm span, and as you get this way, you get larger arm spans. And so since D is to the right, that must be somebody who has a larger arm span. That's got to be Michael Phelps. Okay, sorry, I'm getting an email here. So that means Candace Parker is C, Michael Phelps is D. And I'm going to write this like this. They have the same height. And I'm going to put parenthetically at the same level on the height axis. But D shows a larger arm span. Okay, let's look at the kangaroo and the eagle here. Members of the largest species of kangaroo are often about 5 feet tall, and these kangaroos have very short forelimbs or arms. It also happens to be the case that they use their tails for balance. It's kind of a funny thing. Let's see, members of the largest species of kangaroo. So they are tall, kind of tall, but they have short arms. And so the shortest arms on our graph is A, and that is because it is the closest to this side of the arm axis. All the rest of them up here have longer arm spans, and so A must be the kangaroo. I'm going to put the point, I'll zoom in here, shows a not so tall animal with short arms because it is not that far out on the arm span axis. Okay, that means the eagle must be, I'm going to do the eagle in black here, B. So let's look. I'm guessing B is the eagle, and let's see if I'm right. Bald eagles typically have 29 to 42 inch arm spans and have a wingspan about 8 feet. So they're not that tall. They're typically 29 to 42 inches long and have a wingspan of about 8 feet. So they are much wider than they are tall, which is exactly what we said about point B. It's short because it's not that far up on the height axis, and it's a big arm span because it's way far out there on the arm span axis. Okay, so B is not that far up on the height axis and is quite far out along the arm span axis. And if you were not aware, you can totally see bald eagles right here in Columbia down at Eagle Bluffs. It's a conservation area that the Missouri Department of Conservation takes care of. You can see all kinds of really cool stuff there, like egrets and herons, and but there are several pairs of nesting eagles down there. It's kind of cool. And I think that's all we printed. I'm just going to check the paper copy. So that should be your homework for today. Thanks for watching.